Hello everyone. We have been learning about the linear inequalities, and in the previous videos we have learned to represent the solution of a linear inequality either in the form of an interval or in the form of inequality or representing the solution on the number line. In this video we will learn to represent the solution of a linear inequality on graph. What is the graphical representation of the solution of a linear inequality? That's what we are going to discuss in this particular video. We know that ax plus by plus c less than 0 or ax plus by plus c greater than 0 or ax plus by plus c less than equal to 0 and ax plus by plus c greater than equal to 0 are all the forms of the linear inequalities in two variables. We are going to represent the solution of them on graph now. See, we know about linear equation in two variables, that is ax plus by plus c equal to 0. This is an equation. And we know that if we draw the graph of it, then that is a straight line. Graph is a straight line. In case we want to draw the graph of them, first we will take the corresponding equation of these, any of the inequality, and then draw the line on the graph. That line divides the xy plane in two regions. They are known as the spaces of the solution of the equation. Same way, we will be finding the lines represented by these inequalities also will be dividing xy plane into two spaces. We have to find which is the space representing the solution of the inequality. So here we have to learn the algorithm. What algorithm we are going to follow to find out the solution by graph? First one is that we will find the corresponding equation of these inequalities. The corresponding equation will be in the form of ax plus by plus c equal to 0. And then we know how to draw the graph of this particular equation. Second point, we will have the graph, the line. When we are going to draw for this, we will see what type of inequality it is. If it is in the form of less than equal to 0 or greater than equal to 0, it means that line also will be including the solution of this particular inequality, and hence that will be a regular line. But in case it is only less than or greater than, then we know that the line is not the part of the solution. This is open space. These are open intervals. And hence we will be drawing the dotted line, that is. Number 3. We will take a point, the coordinates of a point in either of the spaces in which the xy plane has been divided by that particular line. The point should be such that that is satisfying the inequality which is there with us, or which we are going to solve. And then we will see in which space that particular point is lying. It may be on the upper side, on the lower side, or the right side or the left side of the line. And in which space that particular point is lying, that space we will be shading, and that shaded region will have all the points which are representing the solution of that particular linear inequality. We will discuss some of the examples now to understand this particular algorithm. We discussed now one of the example, and we have an inequality that is 3x plus 2y less than equal to 6. To find the graphical solution of this, what we will do first, we will take the corresponding equation to this inequality. So we will write here corresponding equation. That is 3x plus 2y is equal to 6. Then we have to draw the line for this particular equation. That can be done in two methods. That is either by taking some of the points which are satisfying this line and joining that line. Or otherwise, we can convert this into the intercept form. We know what is intercept form. Intercept form is x upon a plus y upon b equal to 1. It means we divide this by 6. And if we divide it by 6, this will be 3x upon 6 plus 2y upon 6 equal to 1. Simplifying this, we are getting x upon 2 plus y upon 3 equal to 1. It means 2, 0 and 0, 3 are the points on line. We plot these points. 2, 0 is the point here. 0, 3 is the point here on the y-axis. And then join these two. But what type of line? See here the sign of inequality, that is less than equal to. It means the line is also representing the solution of this particular inequality. And hence this is a continuous line, regular line. Now we'll take a point on any of the side of this particular space. This is one space, this is another space in which the xy plane has been divided by this line. Generally we take origin. Suppose we take the origin here, then for origin what we are doing? For origin 0, 0. We try to find out whether this line is being satisfied or not. This inequation is being satisfied or not. If we take this as 1, in 1 we substitute, that is 3 into 0 plus 2 into 0 is 0 plus 0 equal to 0. And yes, it is less than 6. It means it is satisfying this particular inequality. And hence the space in which the origin lies is the solution space for this particular region. So we can write here 0, 0 satisfies the inequality 1. So we shade this portion in which the origin lies, and that is here like this. So this shaded portion is representing the solution of this inequality 1. We can write here shaded space is the solution of inequality 1. So like this we can represent the solution of an inequality on the graph. Another example here we have 2x minus 5y plus 10 is greater than 0. First of all, we have to simplify this. We can write this as 2x minus 5y greater than minus 10 by transposing. Now, to avoid this negative sign, we can multiply this by minus 1 on both the sides. And if we multiply by minus 1, this will be minus 2x plus 5y less than 10. This is our inequality 1, which we have to represent on the graph. First, we write the corresponding equation to this inequality, and the corresponding equation is minus 2x plus 5y equal to 10. To convert it into the intercept form, we will divide by 10 on both the sides. This will be minus 2x upon 10 plus 5y upon 10 equal to 1. This gives us x upon minus 5 plus y upon 2 equal to 1. It means minus 5, 0 and 0, 2 are the points on the line. We plot these points minus 5, comma 0 and 0, comma 2. And draw the line, but here the line should be the dotted one because this inequality is having the sign of greater than 0 or this is having less than 0. Line is not the part of the solution. So we will draw the dotted line. Here the dotted line has been drawn. This is representing the inequality part. And now these are the two spaces in which the xy plane has been divided by this. So we have to find out which is the space for the solution of this inequality. For that, as I told you, we can take any point or generally we take 0, 0, that is origin. And for origin, what we find here? For origin, 0, 0. If we substitute these points in 1, what we find? This is minus 2 into 0 plus 5 into 0, that is 0. Yes, it is less than 10. And as it satisfies the inequality. Origin or 0, 0 satisfies the inequality 1. So the space in which the origin lies is the solution region of it or solution space of this. So we can shade this now, and shading is like this, we know. And so we can write the shaded region or shaded space is the solution of inequality 1. So in case the sign is either less than or greater than, then the line is to be dotted 1 because this is not the part of the solution of the inequality. The next example we have to discuss here is x minus y greater than or equal to 0. Why so? In this we are finding that the origin lies on the inequality or the equation. Then origin is not the point to decide which space is the solution space of this inequality. What we do in such case? First we will write the corresponding equation as we do. So we will write corresponding equation to 1. If we write this as inequality 1, that is x minus y equal to 0. Or we can write x equal to y. X equal to y means the slope of this is 1. This is making an angle of 45 degree or pi by 4 with the x-axis. Or we can take points on the line with the help of table. This is x, this is y, because x is equal to y. We can take 1, 1, 2, 2, 3, 3. So 1, 1, 2, 2, 3, 3 are the points on the line. Points have been plotted and joined here. This is the line and this is a continuous line because the sign is greater than or equal to, this is a closed space. Now after plotting the points, after drawing the line, what we will do? We will have to see which is the space, because now these two spaces are in which the xy plane has been divided by this line. So what we do, we take any point either in this space or this space. Suppose we take a point on this side in this space, that is suppose 2, 4. Let a point be 2, 4. This is suppose 2 and this is 4. This is the point. This is 2, 4. Now we substitute the coordinates of this point in inequality 1. Substituting in 1. We are getting 2 minus 4, that is minus 2. Is it greater than equal to 0? No, it is not greater than equal to 0. It means 2, 4 is not lying in the solution space. So we can write this implies that 2, 4 does not lie in the solution space. And hence what we will do? The other space is the solution space, so we will shade the other one. And we are shading it like this. We have shaded the region or the space in which the solution lies. And then we can write the shaded space is the solution region. That shaded space is the solution of inequality 1. This is the way we can represent the solution by graph for any of the linear inequality. In the next video, we will learn about the applications of the linear inequalities or inequations. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.